Hi folks, today we're going to talk about the absolute value parent function. A parent function is a function like y equals something with x. It's like an equation, but a parent function is kind of like the big guy. It's the function where all the other functions come from. So the absolute value parent function is kind of like the parent of all the little absolute value functions that we might deal with. Remember from previous math classes, the absolute value refers to the distance from 0. So absolute value kind of looks like a number that's put in these big old bars right here. So maybe on a number line with 0 in the middle, so 1, 2, -1, -2. Maybe I'm trying to find the absolute value of 2. Well, the absolute value of 2 is its distance from 0, so 1, 2. Likewise, if I were going to find the absolute value of -2, I might go to -2 on a number line, and I find its distance from 0, 1, 2. Notice how both the absolute value of 2 and the absolute value of -2 both equal +2. It happens because absolute value is always positive. So the absolute value parent function is y equals the absolute value of x. Meaning, if I take the absolute value of a number like -2, the number that I get out of it is +2. Its distance from 0 is +2, and together that will make an ordered pair. So my x value was -2, and its corresponding y value was +2. So what I'm going to do is I'm going to move over to my table on the right side, and I'm going to fill in some values. I'm going to fill in some values. So, my process, if I'm given an x value to find the ordered pair, is to take my x value and use it as the first component of my ordered pair, and then the y value that I get out of it is its absolute value, because y equals the absolute value of x. So what I'm going to do is I'm going to take each x, I'm going to find its absolute value, and that's my y. So the point here would be x, comma, y. Now think about the absolute value of -2. If I take -2 and I input it here, the absolute value of -2 is 2. So I'm going to make an ordered pair of -1, -2, sorry, comma 2. If I take an input of -1 as x, the absolute value of -1, its distance from 0, is +1. So my ordered pair is -1, comma 1. That's an equal sign, sorry. If I take the absolute value of 0, that's 0. This is a pretty special point if you remember from previous classes. It's called the origin. I'm going to let you go ahead and finish writing at least your work here since I'm supplying the y values for you. And then I want you to pause the video and graph your ordered pairs on the graph. Remembering that the first component, the x value, is how much you move left or right. And the second component, the y value, is how much you move up or down. These together indicate 1 point on the graph. So pause your video and try to graph your points. So if you graphed your points, you might notice, and some stuff is going to come up on the key attributes box, and that's perfectly fine. But whenever you graph, hopefully, you got something that looks like this. So we have the point -3, 3, the point -2, 2, the point -1, 1, the origin 0, 0, the point 1, 1, the point 2, 2, the point 3, 3. So we're going to go ahead and list some key features about this graph that we notice. It kind of looks like something that you might have done last year in Algebra 1. It kind of looks like a parabola, but it's kind of comes to a point here. It's not quite as rounded as a parabola. So it's not a parabola, it's a V-shaped graph. It looks exactly like a V. It's a V-shaped graph. The vertex of an absolute value function is the same thing as a quadratic function, as a parabola, and I'm talking about those like U-shaped functions that you did last year. That vertex is right down here. It's like the turning point of your graph. So I notice that this graph is decreasing, decreasing, decreasing until it hits this point and then it increases. So the turning point is this one right here. What point is that? That's my vertex, the origin, 0, 0. Remember from last year that the axis of symmetry refers to the line, an axis is an important line, where one part of the image can reflect over and be the same on the other side, and that's what symmetry means. So I notice that this can kind of flip over and become this over here. So my axis of symmetry is right down the center. Right down the center, that's a vertical line. All of these points are the y-intercept. Typically I would write a line for the equation y equals mx plus b, with this being the y-intercept. However, all of these points are on my y-axis, so they're all kind of my y-intercept. So this was my plan, but this is no longer good. The only way that I can write the equation of this line is to refer to its x-intercept, and that would be x equals 0. It's going right through at 0, not -1, not 1, but right at 0. Finally, the domain and range that we want to talk about is the x values and the y values. The x values and the y values we're going to talk about more in depth tomorrow and maybe even the next day after that. But you do have a foundation from Algebra 1 with respect to domain and range. Remember that the domain talks about the x values from the left side to the right side. And so in our classes in Algebra 1, we talk about $, a frog, says ribbit. So that helps us remember that domain goes from left to right. So I'm going to draw some boundaries here on the left side. I'd love to draw a boundary right here, but I can't because of the arrow. And I'd love to draw a boundary right here, but I can't because of the arrow. So one of the things that you learned last year is if you go from an arrow to an arrow, extending to infinity in one direction and the other, then we say that the domain is all real numbers. That symbol was a capital R with a double bar. So all real numbers. The range, $, says ribbit, so range goes from bottom to top. I'm going to take my highlighter again. I'm going to see if I can find a bottom boundary. So this graph comes down, 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 and then goes up, up, up. The farthest point down is right here, so that boundary's right here. So my bottom boundary is all the way down here, and then my top boundary, I don't have one because my function continues to go up and up and up. So all I have is a bottom boundary. All of my y values have to be what than my bottom boundary? Well, my function is above the boundary, so they all have to be greater than the boundary. The boundary also, with respect to the range, the y values, the boundary is also happening right here. this whole thing, but the y value is right here, and that y value is 0. Remember, that's the origin. 0, 0. So the y value for that boundary is 0. All the y values have to be greater than 0. The x-intercept is the part where the graph crosses the x-axis. So again, that's right here, 0, 0. And the y-intercept is the place where the graph crosses the y-axis. So again, that is the origin, 0, 0.